Okay folks, welcome to how to do a calculation based on the heat of neutralization experiment. If you have a look please on page 178 of your red book, you will see a little record of results. So the first thing you're going to do for me please is fill in for the temperature of HCl before mixing 14.8, the temperature of NaOH before mixing 14.8, and the highest temperature reached after mixing, which was 18.2. First thing you're going to calculate for me is this thing, the temperature rise, which is delta T. Delta just means difference. So I'm going to give you 20 seconds to figure out how would you do that piece of maths. Alrighty, so I'm hoping that you have decided to take 14.8 away from 18.2, and when you did you got 3.4 degrees Celsius. Now we're kind of doing this a little bit out of sequence, but I just didn't want to be coming back to the table of results at the very end. So you will have to calculate the number of moles of acid used and which triangle should you use. So the information you're going to have is, say, 250 centimeter cubed of 0.1 molar NaOH. What triangle does that set off alarm bells ringing? I'm hoping now you're all shouting fourth triangle, concentration triangle is the one that we're going to use. So I'm going to ask you now, with these two pieces of information, to figure out how many moles of acid, how many moles of base, using the fourth triangle. You can pause it now, use your fourth triangle, and when you unpause, I'm going to go through the calculation. Okay, so you should be using this triangle with moles on top, concentration to the left, multiplied by V over 1000 on the bottom. You are literally plugging in the information for the moles of acid into your equation. So it should look something like this. 0.5 by 250 divided by 1000, and that's going to give us 0.125 moles. We're going to do the exact same thing with the moles of base, and lo and behold we get the exact same answer. Now this is a 1-to-1 reaction. One equivalent of acid to one equivalent of base gives you neutralization, so these numbers should always be the same. So we go back to our table on page 178 and we fill in these two new pieces of information. In terms of the mass of our solution, I'm going to direct you to this assumption over here, and in some of the questions you will see mention of density, and this is all that it's saying is the density of water is 1 gram per centimeter cubed. So if you have 100 centimeter cubed of water, you actually have 100 grams of water, and if you have to convert that into kilograms, which we will, that's going to be 0.1 kilogram. So density in this, whatever centimeters cubed you have, you're just going to convert that in to grams automatically and kilograms next. So in our experiment we're going to have 500 grams, and that comes from adding the 250, can't write with this, but it comes from adding 250 plus 250. Okay, so this is not going great, but God loves a trier. Okay, so that's going to give us, when we do that piece of maths, 500 grams, and to convert that into kilo, I just divided by 1000 and I now have 0.5 kg. Alrighty, so in terms of the steps in the calculation, on the bottom of page 178 you're going to find them. I'm going to talk through them really quickly and then I'm going to go through them in detail. So the first thing you have to do always is find the moles using your fourth triangle, your concentration triangle for one of your substance, and there's a caveat with that which I'll explain in a minute. The second thing that you're going to do is you're going to use this formula, MC delta T, and you're going to calculate the heat change for the reaction. And again, there's a caveat here. It could be in joules or it could be in kilojoules. Now, I have a silly sentence to remember this equation for this experiment. And the silly sentence is milk in a cup of tea. And as you can see, my tea here is kind of funny. but that helps me to remember MC delta T, especially considering you may drink tea in a polystyrene cup. So for me, that's how I make the link. The third step is very straightforward. You're literally going to divide answer 2 by answer 1, and your answer is going to be in either kilojoules per mole or joules per mole. So again, you just have to be aware of that, because that dictates what happens in your fourth step. And in your fourth step, if you have to convert to kilojoules per mole, you do that, but you have to write your answer with the format delta H is equal to this negative value and whatever your answer is in. If you do not do this, this is how you lose the final 3 marks, and you would be amazed at how many people do that. So just to go through our steps. Using step 1, we're always using the fourth triangle no matter what. You just make sure that the volumes and concentrations are the same for both acid and base, because if they are, no matter what you put into this triangle, you're going to get the same answer. They have done, the SEC have been mean, where they've given you different volumes, same concentration, which meant the moles were going to be different. So you have to do the calculation for both, and you use the answer with the lowest number. Why? Because the ratio is 1-to-1 for that reaction, and the bigger number is now in excess. And as you always know, once we have a limiting reagent, we go with that number of moles. So that's step 1. Our calculation from earlier, we found that there was 0.125 moles of each, and we're now going to use that in step 3. So congratulations, us, tick. For step 2, there's a lot of things here that you just need to get your head around. So MC delta T is the formula. The M is in mass, and it's usually we have to convert to kilograms. Again, you just need to look at your C units, and C is coming up next for help. And I've already referred to this, but whatever volume you have, you assume that's the same amount of grams, and then you just convert that to kg by dividing by 1,000. The C is a thing called specific heat capacity, and it's always going to be given in your question or on your front cover. And its units will tell you whether your answer is in kilojoules or joules, and I'll show you that in a second. Okay, so the last bit is the delta T, and that's the temperature difference before and after addition. It is in Kelvin, but in reality there's no conversion needed, because 273 or 293 minus 273 would give you 20 Kelvin. That's the exact same as 20 degrees. Here, you just have to note that if they give 2 different starting temperatures, you have got to get the average. Okay, so that can be a kick. In our experiment, this was our data. The mass was 500 grams, which was 0.5 kg. The specific heat capacity we're going to use is 4060. Please note that it is in joules per kilogram per Kelvin. So our answer is going to be in joules. And the delta T we calculated was 3.14. So we plug all that into a formula, press pause for yourself, do the piece of maths, let me know how you unpause and come back to me. So this is what you should have gotten, 0.5 kg by 4060 by 3.4. So just to show you how you get joules, Kelvin to the -1 cancels Kelvin, kilograms cancels kilogram to the -1, so the answer you're going to get is going to be in joules. And when we calculate that, 6902, and we're going to use this in step 3. Okay, so we're getting close to the end now. So in step 3, we are going to divide answer 2 by answer 1 to convert to either kilojoules per mole or joules per mole. It is literally that simple, but you have to know what the units of your answer are, because it dictates what happens in step 4. So from our data, we had answer 2, 6902 joules and 0.125 moles. Again, pause for yourself very quickly, do the piece of maths, come back to me. So when you've done that piece of maths now, the answer that you get should be 55216 kilojoules per mole. This is going to, do a little click. This is going to ensure that we now have to do something in our step number 4. So step number 4, finally, the words say convert to kilojoules if necessary, which for us right now it absolutely is, and we have to write our answer in a very particular way. So our answer was 55216 kilojoules per mole. To convert it to kilojoules per mole, I'm hoping you're all shouting at the screen that you need to divide it by 1,000. So when I divide it by 1,000, I end up with 55.2 kilojoules per mole. The candidates that don't score full marks on the maths, stop here. For it to be, the question is always asking you to work out the heat of neutralization for your particular experiment. So to turn it into heat of neutralization, it needs to be written with the delta H value in the front. You need to put in the negative symbol. Why do you need to do that? Because this is an exothermic reaction. Your temperature increased. There was heat given out. So if you don't put in these two little things, as well as having it kilojoules per mole, you won't score 4 marks, full marks. So that is the end of how to do the calculation for the heat of neutralization experiment. Thank you.